Well, no, it's just I met with Jeremy Schmidt,
Well,
an old member.
uh-oh, gentlemen, everybody,
Okay,
folks,
we're on.
are we on?
Yep.
Hello there, guys, Captain, the rest of you. My name's Ronnie Heron, your weekly host once again for this little 1 hour vlog we do every week on Mondays, the SBAU Astro Hour. It's all done for Santa Barbara, California's longtime Astro Club, physics, telescopes. It's the Santa Barbara Astronomical Unit, folks. And once again, I'm on the big Zoom screen with my friends, my buddies from SBAU, most of whom could be physics professors out at UCSB's Broida Hall. Actually, one of them I'll introduce you to in a minute was a science instructor at a local college, now retired. So I'm very humbled to be here. We're located at and supported by the Santa Barbara Museum of Natural History. Getting set for our president's godson, NASA's Ingenuity helicopter pilot for the Mars Perseverance mission, July 10th, a Thursday night. Come find us at sbau.org and weekly right here on YouTube. This is episode number 224 for June 9th through the 15th, and we're going to talk this morning about M27, an area of the sky possibly named after me, the Dumbbell Nebula. High in the east, Hercules, other globular cluster, M92, right behind M13. We're going to visit. Our full moon's named for our strawberry season this time of year. Saturn's two-faced moon, Iapetus, reaching its greatest west elongation today. And speaking of our moon, we got certain visitors, many visits we've taken up there to the craters on the surface of the lunar. But how about checking out 10 big ones down here on Earth? I know of 2 craters, and we're going to learn 8 more. And we'll talk to the guys right now. We're going to go to the silly stuff, and here are the people in charge. Commander Jerry Wilson.
Good morning. Hi, Joyce.
Yep, beloved President Jerry Wilson, married to the very lovely and very outgoing Pat Forgy. What a supporter she is. We did pig out. I didn't eat all day, but I'm just starting to eat again. It is now Monday, following Friday's potluck. Here's Chuck McPartland, Captain Outreach. No doubt about where he stands in that Russian invasion of Ukraine war, and he's married to a Pat. He is an incredible outreach, and she's incredible merchandise manager as well as treasurer. Let's see, joining us in order, Bruce Murdoch, longtime supporter, very intelligent man, become a mentor of me on my computers lately, and also president of the Santa Barbara Theater Organ Society. He's married to and taking care of his wife, Bonnie. Hope she's doing well. Who else is on board? Tim Crawford joined us. He's married to Karen. Tim, long
Howdy
time.
doody.
Yeah. What were you about to tell me before I introduced Tom, our past?
I had the absolute pleasure of meeting with an old friend from SBAU, Jeremy Schmidt, yesterday with Joe Doyle. Jeremy was he's out here for a KITP conference.
Oh, I've heard about that.
Yeah, and so we got together with him over at Joe's house. It was really nice to see him.
For the benefit of the folks that don't know, KITP stands for what?
I have no idea.
Kavli Institute of Theoretical Physics.
And they're centered on the campus of UCSB?
Yes.
Yeah,
It's
one of
one of their centers. Yeah.
one of them.
I don't think
Yeah.
I've ever booked a speaker from there, but I'm here they're doing
We have in
something.
the past.
And
Well, here's
everything-
our former Westmont guy, Westmont science instructor, now retired, ladies and gentlemen, Tom Whittemore. He was
Morning.
a lucky guy and bakes bread and is married to Maureen and sobs himself to sleep every night because he misses that damn lab that he used to have. I'm sure. We have silly stuff and some good ones sent to us this week from President Jerry, who's now going to call him up on stage and get us all in a good mood. And I will do my best to guide you through some of them, maybe throw some of them at the rest of you, especially if I can't see them on my screen. But here we go. These are past silly science cartoons, thought provokers, and then we'll get into the heavy meat of the hour. Jerry, you want to do the double agent consonants meeting of the vowels? Can you call that one up?
Can you see this?
Yeah.
Okay.
Oh, that's a late one. Okay.
Well, I don't do it in necessarily the order I set them out.
Well, I understand that. It's politics entering the math classroom is what it is.
Well,
Is
it's a
this-
comment on our times.
Yeah.
Ah,
Trying to do a neutral math discussion, and he says this reciting Pythagoras theorem. He says
Oh,
the
that's
square
right.
of the hypotenuse is equal to the sum of the squares of the other two sides. And all of a sudden the audience erupts into disbelief. Fake numbers. You're shill
Yeah.
for big trig. Pythagoras recanted on his deathbed. I'm entitled to my own opinion. That's what they want us to believe. Don't tell me what to think. Ha, you trust mainstream math? It's only a theorem. It's a right angle conspiracy, Illuminati symbolism. Further proof that triangles were built by ancient aliens.
Yeah. Yeah.
Wow.
What a time we live in. All right,
Oh, I love
this is the one that they've tied in with yeah, the Wile E. Coyote. Something tells me that a Roadrunner and Coyote incident was involved somehow here. Big rock that I wish I could make that sound he makes going off the cliff. Woo, woo. All right, here we go. These are the six, I guess, no, five apostles and one vowel, Jesus. That would be A going,
These are all the vowels.
Right.
yeah, the
Right.
vowels.
A,
The
E,
consonants.
I, O, U, and sometimes Y.
That's
Mhm.
right. And the Y is the one that sometimes doubles as a consonant, but not really. If you think about it, it's not really a hard tongue or tooth against, your bilateral fricium or whatever. It's like starting with the letter I, isn't it? When you say yodel or yeast, that's a word big in Tom Whittemore's household, or yellow. Those aren't really vowels. That's starting with another vowel. I mean, they're not consonants. Here's the one I like. This new sunspot cluster has raised some concern among astronomers. What's it read on? What's it say?
This
check
check
engine.
Oh, check engine.
Lights on the sun. Lord help us. All right. Time for a tune-up. All right, here's Calvin and Hobbes. I did write all this down in case I couldn't read it. Now let's see if I can find it here. Oh no, I didn't write it down. You're gonna have to enlarge that because they're talking about math. And I've actually thought like this. Can you make it bigger, Jerry? So I can get the words?
Mhm.
Okay, now. So Calvin is saying to his buddy Hobbes the tiger, I don't think math is a science. I think it's a religion. And he scratches his head, a religion? Yeah, all these equations are like miracles. You take two numbers, and when you add them together, they magically become one new number. Nobody can say how it happens. You either believe it or you don't, says Calvin, as we go down to the bottom. And up we go, because he says this whole book is full of things that have to be accepted on faith. It's a religion. And Hobbes says, and in the public schools, no less, call a lawyer. And he says, as a math atheist, I should be excused from all of this. Math atheist. Yes. It's very, very, there's no theories involved with math to speak of. It's all been done, isn't it?
No, there's a lot of wide open problems. Some of them AI has been sicked on.
Is that right?
Yeah.
Oh, here we go. What's this one? The philosopher Plato once said, this is Grandpa talking to the kid. I'm the wisest man alive, for I know nothing. Or no, I know one thing only, and that is that I know nothing. And the kid says, well, how did he know that, Gramps? And he says, his wife told him. Pat. Pat, or Bonnie, or Karen, or Maureen. Okay, we're in the sky, but is this one of your sillies?
No.
Oh, no.
Oh, we're done. Okay, we're into the night sky. All right. Now it's time for me to learn here in the classroom. Tests are real hard in this.
Okay, this is the night sky. Actually, it's the morning sky, 4 a.m. And we see over here Sagitta, this little teeny constellation. And above it is Vulpecula. And right in there is M27. Now we're looking at these things today because the moon is very nearly full. So we have to look away from the moon in the sky, and we have to find things that are very bright. So this one, M27, is a planetary nebula. And also the full moon is this week, but the full moon in this time of year, the full moon is very low on the horizon.
Yeah, it's in Scorpius.
So it doesn't impact what we look at as bad as much as it would at other times in the year.
Mhm.
So
But
we
it's the
couldn't get away
strawberry
with
moon.
looking at M27.
It's the strawberry because of what, the season, or is it kind of reddish?
Atmosphere.
Yeah, it has nothing to do with the,
No, it's with the season
color.
because this is when strawberries ripen.
yeah.
Oh, okay. But when the moon rises in the east, I saw it the other day, it was quite rose colored.
That
Okay.
has
And
more
that's
to
our
do
atmosphere.
with brush fires than anything else.
I know, but that's our atmosphere.
Yeah.
Right. And it's also rising, the full moon will rise in Scorpius, the June full moon's in Scorpius. So
Mhm.
it's low on the horizon.
So you get more atmospherics.
Hmm. Hmm.
This is kind of blown out, but still,
Oh, okay.
it's all right.
What were we looking at there? Was that
M27
the
The apple
nebula?
core.
looked like 27.
Yeah, it was.
Yeah.
What's there to say about it? It's there. Can we see it Saturday
we go.
night?
Yeah.
There it is.
It's up at 4 a.m. if you want to stay that late.
Oh, really? Before then, it's not even visible in the sky.
It hasn't risen yet.
Well, it's pink. What does that mean? What,
Hydrogen.
oxygen?
Okay.
Hydrogen. Okay, President Jerry?
Okay. So this is a planetary nebula.
Huh?
That means it's a star like our sun that blew off its outer layers. It did not so much as explode, although it would have looked like an explosion if you were a planet near it. But what happens is, all stars are a dynamic balance between gravity pulling in and the radiation and energy rushing out. And that defines the star. And in this mass category, when you get to a certain element, not all the way to iron, but you get to a certain element, then the fusion stops. The thing can't crush down hard enough to get to a high enough temperature to keep fusion going. So the outrush of energy stops, and the fall of everything toward the star is now unopposed. And so it's just like you dropping a tennis ball on the floor. It gets pulled down by gravity, and when it hits the floor, it bounces up. Well, when all the outer layers of the star now fall down to the core, when it hits the core, it bounces up. And this is the stuff that bounced out. It sheds its outer layers, is the way it's described.
How long does that take to get all the way back?
Good question. I don't know, a couple days, few minutes.
Couple days. Give me a break. But
Well,
what's
it's
left
not this
behind in
big
the,
when it starts off, right? It's just
What?
slightly larger than the star, and then it grows. I mean, this isn't going to be here in a couple of 500 years.
Yeah, these last on the order of a couple of tens of thousands of years as far
Oh,
as
really?
being
Okay.
visible as the nebula.
Oh, I thought you were asking how long it took for the thing to collapse and bounce back.
that I was.
Well,
Well,
this isn't so much the bounce back. That's part of a core collapse supernova event, but this is more when it before it reaches the white dwarf stage, when it starts fusing helium, that's much more energetic, and that tends to blow off a strong wind, and so a lot of the outer atmosphere of the sun goes out of the star goes out like this.
But had this been a Betelgeuse, a red giant, would we have a black hole instead of a white dwarf in the middle?
That's a red supergiant, and if it exploded in a core collapse supernova, you'd either have a neutron star or a black hole.
But we happen to have a white dwarf. Can we see it?
Right
Yeah, that's
there.
it right there.
Really? Even though it's what, about the size of the Earth?
But it's super hot.
Yeah, it's white hot.
I know, but the Earth is tiny
We
from a
don't
distance.
see stars in the sky based on their size. We see stars in the sky based on their brightness.
Mhm.
Based on their luminosity. Okay. Interesting.
And
So it's there in the picture then. There is a white dwarf in the middle of there.
Mhm.
and it's called
It's what? We
dumbbells.
lost
Chuck, you're dropping out.
Chuck, you're
Okay.
cutting out.
Say it
You're
again.
locked in.
Okay, so they used to make weights to lift by taking dumbbells, bells that didn't have the clapper in them, that weren't of sufficient quality to be used as bells, and basically welding them to a bar so that you would have something that you would lift. And so the shape wasn't like they are today, but it was more like this shape that you see here because it was two bells top to top.
Huh.
And they
So
were
there's-
dumbbells because
there's
they
one-
didn't have the clapper.
There's one bell there. and the
Oh,
other bell is right there.
well, that's pretty common, isn't it, to have opposite jets or
Globes,
explosion or globes?
Yeah,
Yeah.
symmetry. Yeah.
these take all sorts of different shapes, and so
But now this is the color you would see in your scope, mostly hydrogen.
You wouldn't see color in a scope unless you had a camera.
Okay, so they added the color.
No, they didn't add it. The camera sees color in any light. Our eyes don't see color in dim light because
Okay,
you're
so
using a rod.
it's kind of greenish in the middle. Is that a different element than the
Yeah.
pink on the edge?
Oxygen.
Likely
Oxygen.
oxygen 3.
That's oxygen. Okay.
Yeah,
They used
twice
to call it
ionized.
oh, I'm sorry.
No, it's
Go ahead,
okay, Chuck. Yeah, I was just going to say it's twice ionized oxygen.
Yeah, they used to call it nebulium because they saw it in these
oh,
nebulae.
yeah.
But they hadn't been able to reproduce it in the lab because it takes really high temperature and really low concentration, really low density. And they didn't figure out it was oxygen 3 until quantum mechanics came along and they could start to figure out some of the transitions from the electron levels that would give this color of light.
Well, now as prevalent in the universe as water is, it's impossible to exist inside a star, isn't it?
Inside,
I-
no.
H2O. So there's no H2O even as a gas in this photograph.
The
Oh, there
star's
might
made
be
of-
out in the outer parts of it.
Yeah, the star's made of plasma, which is the atoms torn apart.
Okay, so they come together, hydrogen and oxygen, and make essentially fog, I guess.
Yeah,
Yeah,
water's
once-
pretty common.
Although
Mhm.
they're no longer atoms. They're a soup of electrons and protons.
Yeah, down in the white dwarf.
Right.
Interesting.
Well, it
Okay.
all depends on the temperature. Yeah, white dwarfs are very hot.
Yeah, about 100,000 kelvins.
Yeah.
Just seems to me that water is
And yet there's no fusion going on in the star anymore. It just is hot and it's cooling off. Eventually it will cool down, it will dim, it will turn red, and it will eventually turn black, not because it's a black hole, but simply because it's not emitting any light.
What's going on in the white dwarf?
Electron
Right.
pressure, Ron.
What?
Electron pressure.
We covered
Electron
this in an
pressure?
earlier talk. The electron degeneracy pressure is holding it up.
Right.
Right.
Mhm.
Really? But all the neutrons and protons are squished together?
They're down in there.
Yeah,
They're in there. Yeah.
Okay, but protons and electrons, if they're squished together, it becomes a neutron star, doesn't it?
yeah, but that's a more dense situation than a white
Right.
dwarf.
Right.
Then
It
a white
takes a
dwarf.
lot of force to push the electrons into the protons.
Right.
So what you have here is the electrons in the atoms now is trying to squeeze together into the same energy level.
Right.
The Pauli exclusion principle won't allow that.
Right.
So that resists further crushing.
Yeah. And the star is roughly the size of the Earth, Ron.
That's what I understood a while ago, and yet we can see it because it's so bright.
It's very hot. It's extremely hot, especially if you look at it in the ultraviolet. It's just blazing. Okay.
So are we watching an infinite process of expansion and condensing again and expansion and it's just
No.
bouncing like
Oh, no. This is the atmosphere of the star expanding into space.
This has the same life cycle as a smoke ring around a campfire.
I thought you said it was collapsing back down again.
No.
It collapsed,
Oh,
then it
no,
bounced back, and you got the outer layers thrown off.
Right. Yeah.
Okay.
Electrons won't let it collapse further, Ron. Like Jerry said,
now-
it's the Fermi levels will not let the electrons let this thing collapse further. It's just hot, hot, hot.
But
But in this-
I think what he's referring to is the shell of gas, I think, is being held up there by the wind, the wind from that white dwarf, I think.
Well, it's not being held up. It's just moving away.
It's
Yeah, it's
moving away.
expanding.
Yeah.
Oh,
It's
it's moving
expanding,
away.
Tim.
Okay.
You can
Expanding.
take pictures of these. I know M1, which is technically not a planetary nebula, but you can take pictures of that and famously, because we've been looking at it photographically for 100 years, and you can see that the thing has expanded and
Right.
stuff. All sorts of things have changed and shifted. It's simply blowing apart. It's like a smoke ring someone blew, and now it's just going out. And it's going to go out forever until it's so diffuse you can't see it.
Okay, that I didn't know.
Yeah,
the white
thousands
dwarf
of
in there
meters
is-
a second, Tim.
What's that?
Thousands of meters a second.
Okay, I didn't
Yeah.
know that. And the white dwarf in there, Ronnie, is really, really heavy. It's really dense.
Right.
Okay, so even though we're seeing the remains of one star, does this nebula can it make new stars? At least one or two more, or not a bunch, like a big nebula, right?
No,
Not a
this,
nursery.
go ahead.
It's so spread out, that's not going to be happening.
Yeah.
There may be
Right.
knots of density in it, but it's not enough to form a star.
Right. And Ron, this is the fate of our sun. Keep that in mind.
Yeah. And that stuff, if it spreads out and, ends up in another cloud with enough density, may get incorporated into a star.
Yes, exactly.
That's how you get heavier elements inside stars.
Now, if this
Right.
were our sun, you would see our planetary system in that dot. It wouldn't be orbiting around the dot. It would be in there. We would not be able to resolve it.
Right.
So this thing is light years across.
Mhm.
That's about 2 light years across, estimated.
Okay.
Really? Okay.
So if this were our sun, this is halfway to Alpha Centauri.
Yeah.
At
And,
what
it's,
time?
and you said in the talking notes, Jerry, it would take about a 10-inch scope to see that central star. I don't think I've ever seen it.
Mhm. The same thing for the M57, the central star. I remember there is 14th magnitude.
Okay.
So you need a 10 or 12-inch scope to see it visually.
Yeah,
Or
I don't think M57 would take more, I think.
It's
Or
dimmer. Yeah.
It's visible. It's visible when we have the camera at the outreaches
That's
and
right.
show it.
Any
Right.
camera will show it.
Yeah.
Okay. Okay.
That's a sensitive eyeball, Chuck.
Yeah.
Yeah, that's not me.
Well, we've shown binary stars before with a little white dwarf sucking everything off of its larger companion. Is that a similar situation? Is there a shell around those binaries like that?
There can be. In fact, some of the bilateral symmetry that you see in some of these planetary nebulae implies that there is a companion star way down in there.
Yeah.
The one we just saw is not a binary. It wasn't a binary.
We don't know. I don't think we know.
There might be another star in there,
Yeah.
Or a planetary system.
or a whole planetary still orbiting that white dwarf. Okay. Interesting.
Okay, now we're moving on to 11 o'clock in the evening.
Mhm.
Okay. And up here we see the keystone of Hercules,
Mhm.
right there. And this is the famous globular cluster M13, which is the big boy of this constellation. But today we're going to talk about M92, which is out here. So if you want to get to it, you go look at this keystone, which is an easy geometric figure to identify. And you start here and you go through there. And then you go out here the same distance and drop down a little bit, and there you are.
Hey, Jerry, may I add something?
Sure, go ahead.
Yeah. The keystone contains the solar apex, and that's where the sun is dragging all of us, this portion of the sky.
Yeah.
Up towards the keystone. It's kind of interesting. So when you look up the keystone, you know where you're headed.
We're heading toward that? Wow.
Oh.
We're in our rotation around the galaxy.
Right.
Oh, wow.
We're heading toward a big globular cluster.
Yeah.
No.
Well, just the general regions around the keystone of Hercules. Yeah, general region.
Yeah, those things may be moving away from us too as part of the
Right.
rotation.
Yeah.
Okay. Fascinating.
Okay.
Mr. President, you didn't want to broach that subject of the stuff you sent us, the extra website and
Well, we're
somebody's
still
thing?
working on it, Ron.
We're still working on it. The display program I was using does not remember the order I put things in. So I have to switch back to the other things to get going on the program again.
Boy, that's a beautiful image.
Yes, it is very nice.
A
This
lot of
is
stars.
M92. It looks very much like a nice globular, tight globular
Hmm.
to M13, smaller but very similar.
Yeah.
Now, in the write-up that I put in our talking points, so we'll all be on the same page,
Hmm.
it says that this globular cluster is 14 billion years old, and that's older than the estimated age of the universe.
It's older than dirt.
That's based
Yeah.
on earlier data. So now it's put at about, I think the best estimate I've seen was about 13.4 billion years ago. But there are other values of it too. Now, when I was first starting out in astronomy, the idea or the distances and many of these numbers that you associate with astronomy, if you got within a 50% error bar, you would do pretty well. But that was in the 1950s. So the instruments have got better, the telescopes have got bigger, and people have studied these quite a bit. So it's not a 50% error bar in this case. So it is up there with the very earliest objects in the universe. And probably within a billion years of when the universe started, this thing was like it is. It's very old stars. They're smaller stars. They don't have short lifetimes. They have very long lifetimes.
It might not have been as dense as this because as they age and they interact and throw out stars, they evaporate a little but get denser.
Yeah.
I'm confused on one thing, and well, probably several, but with the expansion of the universe,
Yeah.
shouldn't these stars at their age be further from us? I mean, it says it's
They're
27,000
gravitationally
light.
bound to us. I mean, it's gravitationally bound to our galaxy, so it's not moving away.
So,
Yeah.
so that,
This is not at the edge of our universe in position.
Right, Tim.
Close to it.
that's what I'm failing to recognize here.
Yeah, this is a
So
neighbor,
about
Tim.
26,000 light years away from us.
Yeah.
But a lot
And,
of those
Tim,
stars,
this is just a, this is a neighbor.
Yeah.
Yeah, this globular is a neighbor, Tim.
Say
So
it
it's
again,
like
Tom.
Chuck said, gravitationally bound.
Yeah.
Okay.
That's
It's
wondered
orbiting.
about our center of our universe.
Yeah, it's orbiting
I mean,
Center of our
our
galaxy.
orbiting Milky Way.
galaxy, sorry.
would it be fair to say that if you were on a planet around one of those stars, your night sky wouldn't exist? It'd be just bright as hell, and you'd be
Pretty
like
bright.
Be pretty
light
bright.
weeks. You'd be light weeks away from fellow stars around you, and
Yeah.
they'd probably look like suns, wouldn't
The
they?
euphemism I read was that you could read a newspaper at night if you were in the core of that globular cluster.
Huh.
Provided the thermal radiation didn't get you.
Yeah, and the paper might ignite, but that's another story.
But none of the stars in that are big enough to be named, have names, or even have exoplanets that we could see for, transiting.
The chance of exoplanets is somewhat small because these are metal poor stars. They're from before most of the heavy elements were made, and
Yeah.
they haven't made them. And I mean, they're making them, but they haven't spread them out.
But there's got to be a reason they think it's 13 billion years old. I wonder what it is. Did we capture that or
The stars are that old.
okay,
Yeah.
but they were made right after the Big Bang?
Not exactly the first stars. That would be population 3 stars. They named everything, in my view, backwards.
Yeah.
Oldest stars are population 1. That's what we see at night. The next ones are population 2, which are older metal poor stars. And then population 3 is the hydrogen stars at the very, very beginning. Giant stars, high temperatures, fast, short lifetimes, made elements, made metals, and blew them out into space. And then these stars formed.
Yeah, I
So,
think Ronnie's on what I was confused on. It's if it's the age of the universe, that's why I was thinking should be kind of further away from us, but I'm seeing that wrong.
Why? Why?
I think
It's
No, Tim,
gravitationally bound to us.
we're expanding together.
yeah. So it's inflation that did this.
We're kind of in
No.
the same space.
yeah.
No, it's
Same
gravitation.
space.
It's gravity that's holding it to us while the space
That's right.
expands.
That's right. And I was just looking at this image, and these stars are so tight, Jerry. If you look towards the lower left, it looks like there's a distant galaxy down there. It's kind of lower left, right there, where
Yeah,
your
there's
hand
one
is.
there.
That could be a galaxy way, way, way in the distance.
Yep,
You know, like
Probably is.
M13 has 6207.
it
You
has
know,
two in the background and
okay.
yeah,
One
It's
of the
just that the
que
stars are so tight, you
yeah.
know, anything smudgy might be a galaxy.
yeah,
I
one of the questions I get, Tom, out at outreach is when I tell them that it's like a snowball of stars and it gets
Hmm.
more dense as you get towards the middle. And
Hmm.
they said, well, wouldn't you run into one another in there?
Just,
And so that's one of the questions I always get. And I said, no, I think there's a lot of space in there,
there
but the
always is space, there's always a
yeah,
lot of space.
But
Yeah.
there are what are called blue stragglers in some of these dense globulars where
Hmm.
it seems they're anomalously young and massive, and it seems that they've formed from a collision of two of the lower mass stars.
Yeah.
okay.
But aren't
my
most
eye
lower
looks at
mass?
these things and I spot asterisms like this little arc right there.
Isn't that neat? Yeah, I noticed that
Yeah,
arc.
I saw that. Yeah.
And then there's a little tail down here.
Hmm.
Are they mostly red dwarfs?
No.
Oh, no, no.
Well, you said they're smaller stars. Aren't most small stars red?
Red is cool stars.
Yeah.
Oh,
These are not massive stars, and there probably are some red dwarfs in them where just you don't see them, or you see
Yeah.
them only in Hubble pictures.
Yeah.
We can only see the red dwarfs that are near us.
so it's a temperature thing. They can be the
Yes.
size of a red dwarf, but much hotter.
And that's what
Uh,
that lady in Harvard University back in when she was a computer, as they called the women that did the data
Oh,
research.
yeah.
She made the OBGY, well, I forget the acronym. Yeah, she rated the stars per their temperature.
Yeah, KMRN.
Yeah.
I
Okay.
bet you old man Messier
and,
would
and,
love to know what we know now.
and it's all mass, Ron. It's mass. When you say size, it really should be mass because the more massive you are, you can be much smaller in diameter.
I just wonder what they're fusing at the time if they're that small. Are they getting close to
Hydrogen.
iron or are they
Hydrogen. No,
barely?
no, 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 no. These stars are not massive. They cannot make the heavier elements.
Right.
So,
Heavy
so,
elements.
so way back at the beginning, they're still on hydrogen, hydrogen to helium.
They're still on the
Fusing?
main sequence, a bunch of them, but when you see them start turning off the main sequence is how you age the cluster. That's how you figure out how old it is.
Right. Right.
Wow, man,
Oh,
old man Messier must be turning over in his grave.
No, he got this one, M92.
Yeah.
He didn't
This
know
is a-
what it
this is a
was,
nice-
though. We know the details. Okay,
This is a
what is
nice
it?
photograph from Jay Huang. It represents the strawberry moon.
Mhm.
This is a moon that is either in the dawn rising or in the evening setting, and that's why it's red here. It's not because it's a strawberry moon. The strawberry moon is just the season for strawberries. But it'll happen. When is it happening this week?
What's
pretty
sticking up
close.
out of? I'm sorry. What's sticking up out of the clouds over here on the right?
Oh, it was taken on a mountaintop with, you can see a hill over here, and you can see a TV antenna up here, and probably
Oh,
at a remote observatory.
so that's supposed to be a red moon. It's more
This
yellow than red
is
on my.
Again, Ron, it has nothing to do with the color of the moon. It's the season.
right.
Oh, I see. Okay, but
This
all moons year round, the minute they rise, they're shining through thicker atmosphere because they're right on the horizon. And now if they're overhead, right?
if they're overhead,
That-
it depends on what the atmosphere's got going on. If you've got a lot of brush fires going on, the moon is going to be either obscured or pink like this directly overhead. This is, by the way, taken over San Francisco,
Oh,
the fog.
oh. Where's Jaws in there?
Yeah.
He's way down.
wow.
Wednesday morning at 12:44 a.m. That's when the full moon is full.
Okay. Okay.
Okay.
So tomorrow night.
Hmm.
Yeah.
That means Saturday night star party will be limited.
Well, it's not coming up till a little later. Each night it's about 40 minutes later rising. So
Will we get any of it? Will we be able
Oh
to
yeah,
look
near the
at
end. Yeah.
craters? Okay.
So this is a shot of the sky from the planetarium program,
Mhm.
about 90 minutes before sunrise, before dawn. You can see Venus over here in the bright. It's now the morning star.
Mhm.
Up here is Neptune and Saturn. And down here is the dwarf planet Ceres. So also known as an asteroid, but I've seen it classed as a dwarf planet. Confuses me. Anyway, the reason we're looking at Saturn is that tomorrow or on June 12 at 4 a.m., the same time as that picture, as the map was up. This is Saturn in a wide angle field of view, and this is also from a computer program. It's not a picture, an image. This shows the moons of Saturn clustered around Saturn. Titan, which is easy to see, is a small red image. If you can get a good picture of Saturn, you can easily see Titan. Now, Iapetus is out here, and Iapetus is that moon that is half black and half white, depending on which side is facing us. When it's on this side of Saturn, we see that because it's tidally locked to Saturn. So when it's on this side, we see its white face, and so it's very bright and you can see it. When it's down here, it's the dark side toward us and you can't see it. It's very dim. It changes it changes its brightness. So this is the time to look at it. The morning of the 12th, what is that, Friday morning?
Yeah.
No,
Thursday.
Thursday.
I think it's
What's that?
Thursday.
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 Mhm.
Thursday morning at 4 a.m. Look at this, you'll see this configuration and you'll be able to see Iapetus.
Well,
Do you suppose, Mr. President, that black and white is the same colorations or the same stuff that made the large heart on Pluto?
No,
It's different. It's not
yeah, this one,
nitrogen.
Chuck, you want to explain why it's black and white?
It's tightly locked, and one side seems to be getting hit by there are big clouds apparently of what are called polycyclic aromatic hydrocarbons, so dark colored junk like dust around Saturn. And several of the moons, like Phoebe, when Cassini was coming in, are very dark and they're covered with this stuff. And it seems like Iapetus, um, because it's tidally locked, the same face is kind of the leading edge, and so it's getting swacked with this black stuff that covers one hemisphere.
Okay,
Wow.
okay, say it one more time.
So it's traveling. It's basically plowing its way through a cloud, although it's not a very dense cloud of these polycyclic aromatic hydrocarbons that are dark dust,
I never could do that.
and they coat that side of it.
That's where everybody dumped their used motor oil.
Yeah, and
Iapetus itself would be white like snow,
yeah.
but these things, the polyaromatic hydrocarbons are black like soot. And it's picking it, Iapetus picks it up on one side.
And on that side, it then absorbs more infrared radiation or it gets warmer, and the ice underneath kind of evaporates and then recondenses on the other side. So the other side ends up getting coated with even newer ice.
Mhm.
But it's tidally locked even though it's further out than the other moons?
Yep.
Are they all tidally locked?
Most moons in the solar system are tidally locked, especially if they have any appreciable size.
Including ours.
I'm always
Well,
amazed when you say that word, Chuck.
Polycyclic aromatic.
Yeah, I'm
Well,
always amazed.
these moons have been doing their moon thing for 4.5 to 5 billion years. So it gives them a lot of time to tidally lock up.
but my
Just like
understanding is Saturn is about twice as far as Jupiter from us, and yet the
That's
Jupiter,
about right.
mhm.
okay, Jupiter, you can see the Galilean moons. Can you see these, even though they're twice as far away in
Not
your
with eyeball.
with an eyeball?
Not
No,
with eyeball. You can
Oh,
see the
not
four
with eyeball.
Galilean. You can see the four Galilean moons in a pair of binoculars. You might be able to get Titan in good binoculars if you hold them really steady.
Titan is
Yeah.
tidally locked to Saturn, huh?
Yeah.
Be damned. Interesting as hell.
In
Okay.
fact, with a sort of normal sized backyard telescope, like 8 inches or more, you can see more moons around Saturn than you can around Jupiter.
That
But
one's
those
really
four,
washed out, Jerry.
those four we can see around Jupiter,
Okay.
they're all tidally locked.
Yes.
Ganymede and Io, and okay. Interesting stuff. We're going to be out there at the museum anyway. Anything else you want to interject real quick, Chuck, coming up?
Coming up, no, we had, the star party on Saturday. We're doing Refugio State Beach on Friday.
Oh, the night before.
Yeah,
Maybe I'll drive out there.
assuming good weather.
Yeah,
Lost all
right,
of,
provided.
yeah, palm trees came down out there, didn't they? What is it? It's washed out, sir.
Dude,
Well,
this
it's not as washed out as it was.
Thank you. This is
Ah,
a
there
map
it is.
of this is a map of North America.
It's my
Down,
angle.
down
fixed it.
here is the Yucatan Peninsula,
Mhm.
and right there in that white dot is the Chicxulub crater, which is not obvious to a casual observer. It had to be discovered by oil people drilling holes looking for oil and drilling up oil. And they had some profiles that fit the existence of a crater. So that is how they identified this crater. This is the impact that killed the dinosaurs, all the non-flying land dinosaurs. If you ever wondered what a dinosaur tasted like, it tastes just like chicken,
Yeah.
because chickens are dinosaurs.
Right? They were the predecessor of the chickens.
Yeah.
And
A pre-chicken.
this crater, the Alvarez family, I guess father and son, had found this layer of iridium all the way around the Earth that matched the Cretaceous boundary where the dinosaurs went extinct, along with carbon, So there were fires and they said, well, iridium comes from meteorites. We should look for a crater that's around 180 to 200 miles across from a strike that would have caused this mass extinction. And nobody could find the crater. But somebody who went to their talk where they were presenting their results was a petrochemical guy, or more like a petroleum geologist guy. And he went to the talk by Pemex about this ring they found of what they thought might be a crater. And he said, man, you guys ought to talk to the Alvarez family. And that's how they found the Chicxulub impactor, the one that killed the dinosaurs, the smoking gun.
And after that discovery, or putting two things together, it was noted that the layer of iridium around the Earth was a variable thickness, and it corresponded to radiation out, or radiating out from this area. So
In other words, dating back 65 million years.
65.
Yes.
Well, what number on the periodic table is iridium? Does anybody know?
Mm.
Is
It's
it
up there.
manufactured in normal stars before the iron?
No,
No,
it's
no.
not. It's
Well,
more
where
for
does it
neutron star collisions, although you can form it with the R process in red supergiant stars.
But do we have veins of iridium anyway without this layer?
Yeah, not veins. I don't think it collects quite that much, but you can mine it.
Iridium is number 77, and it's between osmium and platinum.
Then, yeah, not
It's
far
a-
from gold.
Yeah.
No,
It's a metal.
it's two from gold.
Yeah, 79.
Do you suppose it has any rare earth properties we can use that China owns? And
So far, we can't make batteries out of it, but it has really good thermal expansion coefficient properties, so that it was used as the standard of the meter in Paris at the National Bureau of Standards there in Paris.
Yeah, it's not a rare earth, Ron.
No, it's a
Oh,
metal.
it's not. Does it radiate? Does it? What's the word for when radium and
It's not
It's not
radioactive
radioactive, no.
it's not radioactive? Okay.
in general. I mean, I'm sure it has radioactive isotopes.
Yeah. So anyway, this
What
is a
its half-life.
cross-section of the crater.
I'll be damned.
This is
6
lower
miles across. That rock
What?
is 6 miles.
kilometers.
The rock was estimated to be between 6 and 9 miles across.
Right.
Well, it was an asteroid,
Yeah.
obviously. Wow.
Could have been a dwarf planet.
Yeah. Well, it had a lot of metal, obviously,
Yeah,
so
right.
probably wasn't in hydrostatic equilibrium.
Only the dinosaurs on this side of the Earth could see it. The other side of the Earth, they just felt something, probably, I guess.
Mhm.
Okay. Did it make Yucatan Peninsula? Do you
No,
suppose?
No, no.
Oh, it
Yucatan
didn't.
was already there.
All right.
Oh, I didn't mean to show this one, but as long as it's here. I saw this on the internet
Hmm.
and it gave me the idea for doing the craters. But I looked at it and I thought, these don't look like different craters. They look like the same crater doctored a little.
Yeah.
And so these don't look anything like what this is really like.
Yeah, and there's some nice sort of misspellings in there telling you this is somebody playing around.
Yeah.
South Africa.
Well, the upper left one is not a crater, but it's a part of the Earth they want to rename
I think
Gulf of
they're
America.
blaming the Gulf of Mexico on
Yeah.
Okay, this is the end. It won't go any farther with that software. I got to go back to the other.
You had them all listed.
I do, and I'm going to
Okay.
it.
All right. The one in Arizona, we're going to get that one.
Well,
Yeah.
so
All right.
this is in South Africa. This is called the Verdefort crater. It's 2 billion years old, approximately 300 kilometers in diameter. The crater is the largest and oldest confirmed impact crater on Earth. The other one that we just looked at, Chicxulub, was 65 million years ago. This is 2 billion years ago. So these
Wow.
little squares in here are farms. There's a town in here. So, let's see a city over here. This was a big honking crater.
Yeah.
All sorts of towns down here, roads going all over the place.
They can make the size of the rock by the size of the crater.
Somewhat, yeah.
So was this bigger than Iridium 65 million killed the dinosaurs 6 miles?
Mhm. Yep.
It's much
This was
bigger.
bigger.
This is
Oh,
a cross section of that crater. This is the town of Johannesburg, South Africa, showing the
Oh, my
crater here. This line, this dark line here, that's today. That's the level today, present surface. This is what it looked like shortly after the smoke cleared. Was these shapes and stuff here. And now it's eroded down to this level.
I have a question online for you, Jerry.
Yeah,
Richard wants to know, would such an impact compromise Earth's atmosphere?
would definitely impact it, no pun intended. So,
Yeah, things would heat up all over the place. You have fires all around the world from Chicxulub. And you had acid rain for quite a while because it hit limestone.
yeah. Now, 2 billion years ago, we had life on Earth from 4.5 billion years ago. So it couldn't have permanently affected, well, it could have, I don't know. That's a good question. Tell him thanks.
He's hearing you.
Oh, okay.
He had another comment, but I don't know if we want to get into it because it's on the expansion and dark energy, dark matter, and that's a completely different subject.
Well, ask it anyway.
Okay, well, his comment was that, I'm concerned about some of the assumptions that are associated with this idea of expansion. We have to create dark energy to push and dark matter so it doesn't fly apart. And later, commented saying that I would say it is consequence of layering on conclusions from faulty assumptions. And I commented that we don't even know what some of this is.
Well, he's got a point there. When astronomers and physicists don't know what they're dealing with, they put the word dark in front of it. So
Yeah.
if he's got a better idea, let's hear it. But yes, we can measure just real briefly, we can measure the speed of stars going around in the outer rim of the galaxies. And compared to Einstein and Newton's gravitation theory, they are moving too fast. So they do not conform to that rule. So from there on, it's speculation. Somehow the gravity out there is stronger than it should be, than we were led to believe it is from the matter we see. So from there, make a hypothesis, test it.
And the best word there is hypothesis.
Yeah.
A
Well,
lot of this is undiscovered science, I think, Richard, and it's just
well, you hypothesize this halo of dark matter because it would have sort of a spherical distribution around the galaxy.
Right.
But there is this bullet cluster that has been imaged in X-ray and infrared and visible that shows two galaxies have collided. And the whole thing about dark matter is it doesn't interact with electromagnetic radiation, and it doesn't interact except gravitationally with other matter. And you can see where these two galaxies have hit, and the dark matter has not interacted. You can sort of map where the luminous matter is and where the non-luminous matter, the dark matter would be. And you can see where the gas and dust gets left behind, but the cloud of dark stuff, sort of continues on.
there you go, Richard. I'm glad these guys are here. I can't do as justice on just replying. They do a good job.
Well, come to our December meeting, Richard, because Tessa, our secretary, is going to have a whole half-hour talk about dark energy.
This one is the Sudbury crater in Canada. And there's another crater up here.
Wow.
So, and you
One
can
of
see
the
all the towns and farms in there.
And a lot of nickel deposits. There we go.
Yes. A lot of these things are sources of minerals, a lot of these craters, and they've been exploited. And that's where this guy Barringer, when he saw the meteor crater in Arizona, he bought it because he thought there's mucho iron under that. Turns out it was all shattered little shards. It was not a big mother lode.
Yeah, there were microscopic droplets of nickel iron all the way to Kansas from the Arizona impact.
So this would be, go ahead.
I don't suppose there's ever been a rock from space that's made mostly of gold, is there?
Not that I know of. There is a rock in space that's made of a lot of gold still out there.
Really?
Potentially.
But people speculate that's where the gold on Earth comes from, but other people speculate, no, it comes from our core brought up by volcanoes.
But most of them are like Chuck's pet rock. It's nickel and
Yeah.
Or
lead
they're
and
just gravel.
gravel.
Yeah, most meteorites are stony, but the tough ones that survive are the metal.
Now this is a map. This is a geological map of Canada above in Quebec, and you can see this watery ring right there. That's the crater, and that's this crater, and it is called Manicouagan crater.
Wow. Yeah, it's definitely a crater.
Yep.
Become one of the 10,000 lakes they have up there.
And this is the Barringer meteor crater in Arizona. Probably the luckiest meteor strike ever because you can see how close it came to the visitor center.
You suppose when it struck, it was a desert there, or might it have been a forest?
I don't know.
It was only 50,000 years ago, so
Yeah, I suspect it's very much like it is today.
Okay.
it's eroded, so it's not as deep as it once was.
Yeah.
What's it cost now to see it? $20?
I don't know. I've been there, but and my wife paid the bill with a credit card, so I don't remember. It's a dramatic thing to go and see.
Yeah.
Yeah, Barringer went bankrupt on his deal with buying this crater and trying to mine it, but his family retained ownership of the land, so they're doing okay now with the museum income.
Making it back with tourist dollars.
Yeah.
Is it off I-10 by any chance?
Is what?
Is it off I-8 or I-10?
I don't
It's
recall.
off the northern one, whichever one that is.
It's 40. It's
40,
off
yeah.
It was 40.
This is the Lonar meteor crater in India. And this is another shot of it straight down.
Wow.
That's a
Wow.
nice one.
Yeah. This one, the Gozes Bluff in Australia is guessed to be they're guessing at it being the remnants, highly eroded remnants of a crater rim, the compressed material from the impact.
I had a sore on my foot that looked just like that once.
And this is that crater looked at from ground level, from 15 kilometers away.
Wow.
And here's a
Wow.
picture of it from the ISS.
I wonder what that rim height is. It looked like it was about, at least 900 feet.
Something like that would be my guess.
But if it wasn't for erosion and good old tectonic plates, we'd look just like the moon, wouldn't we?
Wind and rain and gophers.
That's right. So this is the Tanami. Oh, no, that's the road. This is the Wolf Creek crater in Australia. I'm not going to show you the map of where it is because it'll be washed out and I don't want to go back and forth between the software. And next we have another Chicxulub type event because you have to know what's underground in order to know the craters there. There's no visible, there's a slight ring of exposed rock around here that could be the eroded rim. But this is the crater itself. This is the Kara crater in Nenetsia, Russia. It's in it's up near Novaya Zemlya, if you know Russia. And the last one is the Popogai crater in Russia, also in Russia.
The 1908 Tunguska event didn't leave a crater, did it?
That's correct.
Not a high visible or big one. It's mostly the trees blown out.
But did I miss? Are these a source of great rocks like Chuck has, like meteorites?
There are lots of nickel iron meteorites around Barringer crater, or there were until they got collected really heavily.
Yeah. This
So
one is been restricted for a long time because it's the world's largest diamond deposit. Now there's a lot of graphite in the soil before the meteorite hit, and the shock wave compressed the grains of graphite into grains of diamond. So they're industrial grade diamonds. They're small and they're imperfect, but they're valuable for industry. And so Russia kept everybody away for a long time.
diamonds are organic, aren't they? They start with coal or graphite, like you said, carbon stuff.
It's a crystal structure of diamond of carbon.
I think pure carbon is not considered organic, although organic materials are ones that contain carbon.
Yeah. Hydrocarbons are organic.
Yeah.
Interesting. Wow. So the only one that's welcoming tourists and charging is Arizona. The other 9,
No,
not
all
big
the other ones you can visit. Some of them are in cities, some of them are on a road just outside of the cities. But
Some of them are pretty isolated.
yeah, and one of them, the Russian one, is restricted.
Fascinating stuff, gentlemen.
Mhm.
As usual, I loved it. And we didn't even get into that star cluster as old as the universe. I guess we touched on it, I
We
guess.
talked about M92.
Yeah.
That's true. That's true. Well,
So going back to dark matter, we talked about either 1 week or 2 weeks ago, we talked about a dark version of hydrogen that results from where we talked about neutrons. And there was a decay mode of neutrons where they decay into a proton and an electron, but the electron is in a state that is inside the ground state of the hydrogen atom, and it does not, for some reason, why it's there, is not clear to me. I'm going to go back and read that article again.
Yeah.
But it generates a type of dark hydrogen, which does account for dark matter. One way of looking at dark matter is that it is matter without electrical charge or without net dipole charge. And this dark hydrogen atom would have no dipole charge.
Yeah.
In the quantum mechanical sense of it being in the lowest orbital, or can hop up to the other one. So this dark hydrogen is proposed by the author of that paper, which you can go back and see, I think 1 week ago or 2 weeks ago.
Yeah.
Send us a note if you want a reference to it. Again, I'll send it to you.
Jerry, I just
Hey.
want to mention that at Ed Hat this morning, Maureen pointed out to me there was a really good article done by a scientist. Her name is Caitlin Casey at UCSB. It's the largest map of the universe, and it's called Cosmos Web. Have you seen that, Chuck?
Yeah,
Ed Hat?
that showed up yesterday on Ed Hat. Yeah.
Yeah,
Oh.
yeah. It's just an amazing article.
So the cosmic web,
Yeah, called Cosmos, capital COSMOS, Cosmos. Probably stands for something. And then slash web, -web.
Cosmos web.
Yeah, and they were comparing it to the Hubble Ultra Deep Field. Saying
Right,
in the
right.
Hubble Ultra Deep Field, if you put it at the same scale as this map that they've made, it would be about the size of a piece of paper and have 10,000 galaxies in it. But if you take their Cosmos Web that they just produced, it would be 13 feet by 13 feet.
Yeah. It's a really neat article. Thanks, Chuck.
Is it somewhat like the cosmic microwave background? All
No.
the splotches
No,
are
no.
totally different thing.
It's mapping galaxies, basically.
Yeah.
And it has nothing to do with cosmetology.
Yeah.
But imagine, since both the Hubble and the Webb have got their dinky little piece of sky filled with thousands of galaxies, well, imagine what the whole damn circular interior of the sphere would look like.
We need a recording of Carl Sagan saying trillions instead of billions.
Well, that about does it. I learned a little. I just hope I keep it all. Number 225 will be next week. And tell your friends about us. Come join us and be ready for Martin Kakin's speech about ingenuity on Mars in about 2 or 3 weeks.
July 10 at 7 o'clock.
And that's on the Thursday the 10th.
Yeah.
In the meantime, how do we say goodbye in astronomy's, Mr. Chuck?
Asta Nebula.
Hasta